Hi, it's Jan Beta, and today I want to take a look at a new version of the RGB to HDMI adapter for the Amiga that I presented in previous videos, 2 videos I think. There is a new version of the adapter for the big box Amigas that have the dedicated video slot and use the old style DIP Denise graphics chip. That means this is aimed at the Amiga 2000 and the Amiga 3000 models. So let's take a look. So here's the new board, and as you can see right away, it still uses a Raspberry Pi Zero that you plug into this header here. And it's basically the same design as the original one that Copper Dragon designed. But it adds one more chip. So yeah, it's basically, otherwise it's basically the same as the old original adapter. And it just slots into this dedicated video slot on the side here. And there's actually a backplate here that we can mount an HDMI port to, and that's the plan for today. And then I'm going to try if this actually works. By the way, I only had the version 1 of this original board, and this only works for the original OCS original chipset Denise chips. It got updated right after I got this, and now has a jumper. The original design also has a jumper. You can switch it to the Super Denise, which works slightly differently than the Denise, and the timings are slightly different, I believe. So you have to set this jumper to the Denise you actually have in your Amiga. And I have a Super Denise, which I installed in a previous video. So I'm going to set this accordingly, and this should work. This is actually a common fault, so if you don't get a proper picture output from this, this might be causing that. And this also has 2 pin headers for buttons that you can basically have one in the front and one in the back if you want, which is pretty handy. So yeah, nice design. Initially I planned on putting one of these original boards in my Amiga 2000, the version that has the jumper for selecting the Denise version, because this has a Super Denise, and this version 1 that I got from Copper Dragon, who also designed this, doesn't work with the Super Denise. So I ordered some PCBs and actually used PCBWay, who also happened to be the sponsor for this video. And they are also my favorite manufacturer for prototype PCBs of all kinds. They currently have a contest going where you can send in PCB design tutorials actually and win huge prizes. So I recommend checking out the link in the video description that leads directly to the contest. And of course, they are also manufacturing your PCBs that you have already designed, or somebody else's design that is public domain that you send in and have your circuit boards made. I recommend checking out PCBWay in any case. I ordered the PCBs before this new version of the adapter board was available, and this is of course a more elegant way to put it in the Amiga 2000. This got donated by Michael, thank you so much for that, and he already soldered everything on there. I'm eventually going to build the version 2 boards I ordered, so you can still see me suck at soldering SMD components at some point. But yeah, for this build I'm using this because it's the more elegant way, and I'm also going to make a custom backplate, hopefully, to have an external HDMI connection. So yeah, let's do that. So yeah, my Amiga 2000, I already have this open. I should unplug the mains. Yeah, this goes in here. There's a backplate here for graphics adapters that you could add to this port. All kinds of flicker fixers and graphics solutions exists for these, but of course they don't have HDMI because it didn't exist at the time when they were originally made. This is a new product that uses the Raspberry Pi, and we're going to use the HDMI output from the Raspberry Pi. I'm not going to go into any specifics about this adapter because I already covered most of that in the previous videos. I'm going to link them in the description again for you to check out in case you are interested. It basically outputs a lag-free full HD video output from the original Amigas, so that's really neat to have. Okay, I think the reasonable way to go about this is to try if this actually works at first. So I'm going to install the version of the software on this SD card in the Pi that is actually recommended for this board. The software varies very much because it's still under heavy development, of course, because this is a relatively new thing. And it might be that the versions are not fully compatible with certain versions of these adapter boards. I read on the forums that there's also some issues that you can fix with different kinds of chips you use and things like that. So yeah, I can't really say anything about that. This version I tried worked with the software that was recommended for that. So I'm going to use the software that is recommended for this by the maker of this. By the way, you can literally use the smallest micro SD cards capacity-wise, not because it's micro SD, that you can find. The software literally is just a couple of megabytes, so I'm using a 2 GB micro SD that I found on the street. Actually, that somebody threw away, probably from a phone or something. It's a 2 GB micro SD I found in the street. Just wanted to point out that you can use small SD cards, and it's even recommended to use an SD card that is 32 GB at the most. So yeah, you don't need a huge SD card for this project. So in order to download the software for this version of the adapter, I am visiting Copper Dragon's GitHub page again. He has all the information about the Amiga side of the RGB to HDMI projects on here. The link is going to be in the video description, of course, and everything that has to do with the Amiga side of the RGB to HDMI project, which actually is applicable to a number of systems, and I think the number of systems is growing. So I'm going to put a link to the general project below as well. Software. Hoglet67 is a person who invented the RGB to HDMI, and Copper Dragon made the Amiga, and the big box variant is made by a person who goes by the nick of Blood Monster. Yeah, so that's probably a very friendly person. I think so, it's just a nickname. So yeah, this is the Amiga video slot RGB to HDMI we are using here. This is the exact version I have. There's some new versions in the works with some added stuff. There's, for example, a capacitor you have to add for some versions, like a 47 picofarad capacitor between pins 9 and 11 of the Pi header. Helps many people. Maybe I have to add that, we're going to see. We're going to go with the software that Blood Mosher actually recommends, so let's try that. That's a pre-release version, okay. And this should have, yeah, this has all the requisite files on it. We should be able to just copy this over to our SD card, and we're probably going to be good to go. And I'm just going to replace everything. Yeah, and it's 24 megabytes, so it's not a massively huge software, as I pointed out earlier. Okay, that's it. And then I'm inserting the SD card. So this just slots into the video slot, like so. And yeah, there's actually some screw holes for building a better connection. But it sits in there quite nicely already. And now we have to, of course, connect the video output from the Raspberry Pi to an HDMI cable. And for now, I'm just going to use this long mini HDMI to regular HDMI cable that I used for the A500 in the previous videos, just for testing. I have a proper panel mount connector for this build that I'm going to show you later. Okay, so technically that should be all we need to do. Yeah, let's just try if it works. Okay, it does work. The television is set up to the wrong aspect ratio. I set it to 4:3 because that's necessary for my upscaled video, but this outputs like full HD, so it's a native 1080p resolution, so we don't need to put this into 4:3 mode. It has some flickering dots here, and that's exactly the problem that Bloodmosher pointed out on his GitHub page. And a workaround would be to add a little capacitor between the Raspberry Pi pins or change the settings in the software. So I followed the links on the GitHub page, and this is what people suggest as a solution: 47 picofarad capacitor between pin 9 and 11 of the header soldered on from the backside. I don't have any surface mount parts, so I'm probably just going to try to use one of these through-hole capacitors, 47 picofarad. That's what I'm going to try to do first. There's also the possibility to slightly alter the settings in the software, and that involves overclocking the Raspberry Pi a bit, which usually isn't a problem, but I'm going to try to fix my issue with this capacitor because the Raspberry Pi is going to run a bit warmer if you overclock it naturally. So yeah, let's try this. Okay, that's connected. It does look like the hack job that it is. Maybe that does the trick. Let's try. That made it worse. Yeah, that definitely got a lot worse in my case with the capacitor on there. Okay, so I have my little push button hooked up to the front thing here, and we are using this to enter the menu now and set the recommended settings after all, because my capacitor fix didn't really fix anything. It just made things worse slightly. So yeah, here we are. We have to go to the settings menu. We can skip through the menus by pushing the button. A short push and a long push should enter the menu. There we are. Okay, we should put overclock CPU to 40. 40 button pushes. Okay, let's do that. And we should put overclock core to 170. That's fun. Bear with me. Nearly there, 170. 170, 60. Did it just crash? It just crashed. Oops. I'm just going to try this until it works, I guess. Okay, I'm going to have to read up on this. This doesn't seem to work for me. So I removed the capacitor again, and it instantly got a bit better, but not nearly as good as I would love to have it. Let's see what we can do. Yeah, it's not going any higher than that. And now it crashed again. So I fiddled with this thing for a while. Took me an hour or so. But I think I found the settings that work for me. I put the overclock CPU on 20 and the overclock core on 80. And it doesn't seem to crash. And I also changed the setting in the sampling menu to sync edge trailing with a +VE pixel clock. Yeah, that's the settings I made. And now it seems to be flicker free, for at least for the most part. It is recommended, because you're overclocking the Raspberry Pi with these settings, to use a heatsink on the Raspberry Pi. And yeah, but this seems to work fine now. That's pretty neat. Yeah, while fiddling with this, I tried different capacitor values, and I settled with a 22 picofarad capacitor. Yeah, I used another through-hole thing there because my stash of SMD parts is very small, actually. Yeah, but this seems to do the trick. So 22 picofarad in my case, and the settings I've just shown, slightly overclocking the CPU and the core, and also changing the sampling edge to the +VE thing, did the trick for me. Yeah, I guess I'm going to check this out for a bit and just play some games and such and see if it remains stable and if it doesn't crash. So yeah, I'll be back in a second for you. through the magic of video editing, you are not going to have to sit through this with me. Yeah, I'm trying some different screen modes here, and this is high-res waste. Let's try super high-res. Yeah, and these don't perfectly work because the clocks are too fast for this method. But this seems to be solid. That's not too bad. The Super Denise modes don't work correctly anyway with this method because the pixel clock is too fast, I think. But I'm a huge fan of using the Amiga in the original lower resolutions anyway, so yeah, this seems to work fine now. At least the low, higher resolutions at least do work with this method. And they don't flicker. They are interlaced modes, but you don't get flicker because this HDMI mod prevents that from happening. That's pretty cool. And I'm actually not really using the higher resolutions anyway. I have to hook up the keyboard so I can actually use this computer. If you are changing the settings and you want them to be the same each startup, you have to save configuration in the menu actually. So I did that for my settings that I used here. And now it boots up fine every time. And I think I get the occasional flicker or flickering line here and there. So I might have to fiddle with those settings a bit more. But all in all, I'm pretty satisfied. So the core temperature of the Pi seems to be 37.93 degrees Celsius. So that should be nothing to worry about at all. And it's been running for quite a while now. I have no idea why I can't overclock this more. Not sure about that. But yeah, as I said, it works good enough. I can't seem to get it any better than this. And I used the initial settings of slightly overclocking. Might be an issue with my Pi, really. But yeah, the picture is pretty stable. There's still the occasional flickering line, there just was one. But I had kind of had the same behavior on my Amiga 500 with this Pi actually, so maybe it's an issue with my Pi rather. Yeah, I left this running for 2 hours, I think, something like that. I had lunch and now I'm back and it's still running. Yeah, and we're slightly under 40 degrees C, so 38.5 or something. That's perfectly fine. I have no idea, as I said, why I can't overclock my Pi a bit more. Probably my Pi. But I'm quite satisfied with the results so far. I am definitely going to try this with another Raspberry Pi Zero as soon as I get one. Yeah, so far so good. Yeah, that's very slightly overclocked, but that seems to be the most I can get out of this system. Let's build the backplate. Actually quite a good idea to make a new backplate because my Amiga is missing one here, so I can put this one here and put the new one that I'm about to make here. And these are threaded, so the plate itself is threaded and the case is not. And I want to use this as a template, I think, because that's going to be the easiest way to accomplish this. And I'm going to use an aluminum plate, I think 0.6 millimeters or something. It's not a very thick. It's roughly, it is very close to the thickness of this original one actually, so that's pretty good. What I'm going to do is to mark this. I'm going to use my special pen for marking drilling holes. These are really cool, by the way. They just have a long tip and only have the actual marker on there. Don't want to miss these again, ever since I found out these exist at all. So yeah, in case you want to get your own, there are various makers of these probably. We want a little flap where we can actually screw the card to. So we should cut somewhere like here at first, I guess. Something like this. Okay, we need a bit of a longer thing there. So something like this. You can actually cut this with a steel blade, like a regular cutting knife. And then we can bend it and it's going to break. And this is hopefully going to work. Yeah. Just weaken the metal a bit. And we should be able to break off the whole piece. Yay! So I'm doing the same this corner here. Okay, there we go. And this is going to be bent in a 90-degree angle. We can also just score this. And we should be able to bend it. Yeah, good enough. It's a bit bendy, but it's going to do probably. Just realized this actually has the English translation of Bohrloch marker on it, Carpenter Pen. Now we're getting to my favorite thing on this channel here. Drilling holes into metal. What could possibly go wrong? I used my awl to mark the spots where I want to drill. Here's the plan. I'm going to drill some nice 2mm holes with my cordless, ancient cordless drill here. And I'm then going to use this tap and die set to tap some threads into this. This is just a cheap set I got a while back, never actually used, but I'm going to try it. If it doesn't work, we can still use nuts and bolts. So yeah, let's drill some holes. And obviously we have to drill more holes on the other edge. Yeah, okay. Let's try to tap this actually. Wow, this feels cheap, okay. This is literally just the cheapest thing that is imaginable. So this is a 3mm or M3 thread. Should probably have... No, that's probably... Maybe that's going to be fine. Let's see. Let's find out. I don't have any professional threading oil, so I'm just going to go with WD-40, I think. I don't know if this is... if these holes are deep enough to even take threads at all. Might have to drill the holes a bit bigger. So I'm widening these holes a tiny little bit with this round file here. It's working! I'm cutting threads! Okay, don't go overboard with this. Yep, should be able to put the screws in now, I guess. If we wanted to. But I need new screws anyway, because these ones are going to go into the existing backplate. Yay! That works! Officially my first self-tapped threads. Nice! And I'm very sure there's going to be people giving me advice or laughing or something like that in the comments. I want to measure the positions of the other holes we need to drill. And probably the best way to do that is in situ. So with the card in the slot. Yeah, it's actually working out quite nicely. Yay! I made a thing that works! Yoo-hoo! And of course, obviously, we need to drill some more holes and cut stuff out to fit the actual connector I want to fit. Let's just do it like this. Should be close enough. You always want to turn it backwards a bit to break off the pieces of metal that it cuts. But don't take my word for it. All I know about this I learned from YouTube videos. I think now would be a good time to file this down a bit, and I'm just using a nail file, I think, because I have that always handy. Now, this bracket wouldn't make much sense if you weren't to fit the connector and the button on there. I want to use the button I already made. I'm just going to shorten the leads a bit because I don't need them that long. And I bought actually a combination. This is a very short mini HDMI to regular HDMI plug cable. 30 centimeters or thereabouts, I believe. It was the shortest one I could find because we don't need a long cable there. And this is a panel mount socket HDMI. So yeah, it has the same on both ends. So we can plug the mini HDMI to regular HDMI cable in here, and we should have our output here. Probably something like this. I'm just very roughly marking this. And we want the screw holes there. And we want our switch here. And we should still have enough room for the card sitting there. Yeah, the question is, I think I just want to drill this out, maybe. Yeah, I'm just going to drill a couple of holes here, I guess. We are going to pre-drill this. That's going to be slightly at an angle, but it's a young beta video. What did you expect? So the screw holes are going to be 3mm holes. And I think for the rest I want to just use my files. Yay! I only ever so slightly misaligned this screw hole. Brushed aluminum. So obviously this is not the most beautiful thing in the world, but it's gonna do nicely. Yeah, it's not too bad. I misaligned the screw holes slightly, but filed them a bit bigger, and the screws are still going to fit fine, I guess. This is actually not too bad. I'm kind of surprised it came out as it came out, if you know my skills in metalworking and things like that. Let's just say I was more worried about this part of this build than the actual Amiga hardware one. So here goes nothing. Ah, yeah. This should actually work really well. That's pretty nice. And I could have cut this piece facing here, of course. But I kind of think it is more stable this way. Yeah, looks rather nice. Should totally work. Just going to have to put the button back in, and we only need a very short cable on that. So we're going to resolder the wire on the button really short. So just shows some of the more promising screws from my spares here. These should all be M3s, so let's see. Guess. Are we good for the holes here? Yeah. Yeah. Okay. Let's see how that goes. All in all, this does look a tiny bit better than I had hoped. So that's not bad. It works. My self-threaded threads, they do work. Yeah, these screws are a bit long, really. But look at that. It looks fabulous. That worked really well. Okay, and this can go here. Here. And we could potentially add another button for the front panel if we ever decided to have a front panel. I could have cut this even shorter. And we're going to use the little cable to connect the HDMI. Should have probably tried that before. Yeah, you can even could put a cable tie on here or something, but I'm just routing it around the socket there. Best of all, I can now fit this here. So my Amiga is going to be closed again from the back side here. I think I said in the first video I made about this Amiga 2000, this is going to be a long-term project of mine. And I haven't even gotten into doing any real restoration work on the case or anything like that. I want to eventually do that. But there's so many things I still want to try with this. And I really want an accelerator card in here at some point and things like that. So yeah, there's plenty of projects for the Amiga 2000. And now for my final trick, I'm looking for an HDMI cable. Okay, now here's the big moment. We're going to try if this actually still works. Let's see, I hope so. Fingers crossed. Yeah, we got a signal from the Pi. The Amiga is still booting up, that's a good sign. Hey! It does work! Yeah, and even my bridge board still starts up, as you've probably heard by the little... That's the PAT chime, actually. The Commodore PAT had that chime. The later PC models had only beeps. Boring PC beeps. But for this one, they got away with using the PAT chime, I think. Kind of a neat feature. Yeah, it does work. Yeah, it works really well. It's actually pretty much lag-free, at least there's no noticeable lag. I pointed out before that I couldn't measure any lag, even with this going through a TV. This is an old television. Early full HD, I guess. So yeah, it's really good. And one thing that doesn't work, you need an external solution for that, which isn't really difficult on the Amiga because it has separate audio out, is the audio through the HDMI. I get the audio from a little speaker I have hooked up here. But I could technically, I think this TV would even support to hook up an external sound source and play that. But I'm using external speakers all the time, so that's not a big issue for me, for my setup. Yeah, this works beautifully. It was more fiddly to set up than I anticipated. But yeah, that's sometimes what happens when you slightly modify things, and the machines are all slightly different. These boards are really timing sensitive, so probably that's why you have to fiddle with the settings so much to make them work. It might just work plug and play for some of you. For others, you would have to add the little capacitor, maybe add another value of capacitor. The forums are full of that stuff, and there are many solutions. Some of them seem to work for most people. The overclocking seems to work for most people if you do it more than I was able to do, probably because my Pi is slightly wonky, I don't know, or maybe it's an early revision that can't go that fast. I'm not sure. However, I'm really satisfied with how this turned out, and the little bracket I made looks rather beautiful for something I made. Yeah, that's all for today. I have more Amiga stuff coming up really soon, and I hope you stay tuned. Hope to see you again on this channel sometime. Thanks for your support on Patreon and on the channel memberships page. And thanks everybody for subscribing and your thumbs and all those things that make the YouTuber's life more worth living. Anyway, thanks for watching. I'm Jan Beta. See you next time. Bye. I'm gonna play more Turrican.